think of an sp3 hybridized atom like carbon. You have, well, tetrahedral carbon. You have 4 sp3 orbitals. So each of these orbitals right here is an sp3 orbital, and it occurs in a set of 4 orbitals, right? So what's going on here is this is an sp3, this is an sp3, sp3, sp3. When you have sp2, remember you're only mixing one s with 2 p atomic orbitals. So you've got 1, 2, 3, and they are sp2 orbitals. And then you have this leftover p orbital. So I'm going to label this one p. So that's an atomic p orbital. Now we look over here, sp, we have one sp orbital and another sp orbital. And then how many unhybridized p orbitals do you see? We've got to have these 2. And if you remember, p orbitals occur at 90 degrees to each other. Okay, so it's an attempt to try to be 3D here, but it's hard to draw on a piece of paper. So this is p orbitals in white. All right, now the reason why I'm showing these is because I like to use them as templates that you can drag down and apply to to your own drawings. So for example, I'm going to refer to these templates when we do these 3 molecules. What I'm going to show you right now is how to draw the orbital picture, the orbital diagram for these molecules. That's going to show what kind of orbitals are involved, where are the sigma and pi bonds, and where are the bonds, like where are the shared electrons between 2 different atoms. All right, so down here is ethane. Let's start with that. Now, first of all, on my PDF, the image didn't show up correctly, so I'm going to correct that as we go. First, let's take this carbon right here, okay? I'm going to draw that carbon down here, but first, before I do that, I need to know some information. What's the hybridization of this carbon, and how many sigma bonds are there? So let's figure that out. Carbon has 1, 2, 3, 4 sigma bonds. So we're going to do one carbon at a time, okay, because this molecule has 2 central atoms. I'm going to do this one next. So I've got 4 sigma bonds. How many hybrid orbitals is that? Well, go back to our chart. 4 sigma bonds was due to sp3 hybrid orbitals. So I need 4 sp3 hybrid orbitals. So I'm going to start with one sp3 hybrid orbital here, and I'm going to have another one here, and another one here, and another one here. And remember VSEPR theory, where the electron clouds repel each other, so the orbitals want to be as far apart from each other as possible. So later you'll learn, you'll review that this is a tetrahedral shape. So that means these orbitals, try to draw them tetrahedral, okay? All right, so once we have that, now I want to focus on the other carbon. Okay, so the other carbon's identical. It's also sp3. To draw that, I'm going to be really careful here. I want the sigma bond here to show an overlap between the sp3 here and the sp3 here. So down here, I'm going to show an overlap like that. This sp3 is overlapping with this sp3. Now this carbon over here is here. It's going to have another sp3, another sp3, and another sp3. So in a sense, I'm taking this template and I'm dragging it down to here for this carbon, and I'm dragging it down for this other carbon. All right, my sigma bond between the 2 is right here. And then I have all these other sigma bonds as well, right? Let's label them all. Sigma, sigma, sigma. I have all those. So I'm going to go back, and remember, hydrogen is a 1s orbital. So those are s orbitals overlapping with my hybrid sp3 orbitals. So that's what these are for. So I'm going to show 1, 2, 3 hydrogens there, and 1, 2, 3 hydrogens here. All right. Now there's electrons being shared. So this carbon, remember, has a valence of 4. So here's 1, 2, 3, 4 dots from this carbon. And then the hydrogen brings another dot or valence electron. This carbon has 4 dots as well, so 1, 2, 3, 4, and then each of the hydrogens brings in another electron to pair up. So those overlaps are from 2 shared electrons in the valence shells. All right, now when we label our sigma bonds, the overlaps are where those sigma bonds are. So this is a sigma interaction. This one's another sigma bond, sigma bond, sigma bond. And then this might help is a little more detail, okay? So for example, this sigma bond here is due to an overlap of what kind of orbitals? Well, this is an sp3 and this is an sp3. So I might write sp3, sp3 there. Whereas these kinds of overlaps here are from sigma bonds that have an sp3 orbital overlapping with the s orbital of the hydrogen atom. All right, so those are the 2 types of sigma bonds that I see here. Now ethene looks like this. I would start with the Lewis structure and just identify the type of bonds you see. Now that's going to help us identify what kind of hybridization these carbons are. Okay, this carbon is sp2. All right, so now I'm going to go up to my template for sp2. I'm going to drag that down. So remember, it's 3 sp2 hybrids and an unhybridized p. I'm going to take that template and I'm just going to bring it down. 1, 2, 3. And remember, VSEPR theory says 3 bonding domains, they spread out, it's 120 degrees. This is what we call trigonal planar. So this is something we'll come back to later. Here's my p orbital right there. So that's for one of the carbons, that's for this carbon. Now let's do this carbon the same way. So I'm going to have this carbon over here, it's going to have its sp2 orbitals here, and it's going to have this unhybridized p orbital here. All right, now it's up to you what order you want to do this, but I would use the Lewis structure as a guide to fill in the rest. So let's do the hydrogens. I've got 4 hydrogens, 1, 2, 3, 4. And then the p orbital is used for the pi bonding, okay? So for that, I'm going to use, maybe I'll use this. Here's the p orbital. P orbitals side to side making the pi bonding interaction. So I'm going to call that my pi bond here. How many pi bonds is it? It's just 1, right? So remember, this whole thing is just 1 pi bond. This is my sigma here. I have another sigma here, 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 and here where they overlap. All right, now it's up to you if you want to draw in the electrons, you can. There's a pair here, a pair here, a pair here, here, and here. And then here you can do 1 and 1 if you want, but they pair together as well. What kind of sigma bonds are these? This is a sigma sp2, sp2. All right, and this one here, this one is a sigma sp2s. Okay? So now, pause the video and see if you can draw Eethane. It's a little bit hard. The template here is for one of the carbons. Okay, so I've started it for you. So here's an sp and an sp orbital. So first, practice going through what are your sigma bonds, what are your pi bonds, what's the hybridization of each of these carbons. Find the template up here and drag it down and do that for each carbon. And let's see how far you get. And if you have trouble, just follow along with me. All right, guys, we're back, and I'm going to go through these as an example. This is my cat, Ginger. She's very cute. She needs a lot of love right now. So for these, I recommended you draw the Lewis structure first, and then we draw the sigma and pi bonds and figure it all out in a simple structure, and then apply it to a hybrid orbital diagram. So I would take this one and just draw a really simple Lewis structure first. So CH3Cl. And don't forget your lone pairs. Okay? So with that, I would then identify my hybridization. So this guy is going to be sp3. And then this one, remember to count the lone pairs as the potential for sigma bonds. So I have 1, 2, 3, 4 places. So I've got sp3 here as well. So remember 1, 2, 3, 4 potential sigma bonds there. So I'm going to count the Cl as sp3 as well. Okay, so based on that now, I'm going to also label my sigma and my pi bonds. So here I just have sigma. So now I'm going to apply my templates. Okay, so I'm going to use my sp3 template. And for carbon, I'm going to say that there's 1, 2, 3, 4. So that's 4 sp3 orbitals for carbon. And then for chlorine, I'm going to do in green, here's Cl. And I'm going to do 1, 2, 3, 4 sp3 orbitals for Cl. And then for the sigma bond, that's here. And then I have my 3 hydrogens. So I'm going to do that here. 1, 2, 3. And there's my overlap between those orbitals. And then I've got my electrons in here, and in here. I've got the sigma between the 2 sp3 orbitals here. And then I've got my lone pairs here. So that's that one. All right. Now with CO2, I would start with the Lewis structure for CO2. So like that. And I've got my lone pairs here. That is due to sp because I've got the 2 sigma bonds and then 2 pi bonds. So sigma and pi. Now for the oxygen, think of it as a sigma, a potential for a sigma, potential for a sigma. So think of it as 3 sigmas and a pi. So that's going to be due to sp2. And this oxygen's the same. This is sp2. So let's use our template for sp2 and sp. So my template for sp was I have an sp orbital this way and an sp orbital that way. So that's the carbon. And then for the oxygen, I have, before I do the oxygen, remember for carbon, I have the sp and I have 2 unhybridized p orbitals. So here's one, and here's the other p orbital. There you go. Because we always have to have 4 orbitals of some kind. So 2 sp orbitals and 2 p orbitals. Now I'm going to go through the oxygen. For oxygen, I've identified that it's sp2. So here's my 3 identical sp2 orbitals. I'm going to do the same thing over here because I have the same thing going on there. And then remember, for sp, there's a set of 3, and then there is an unhybridized p orbital. And see, these are going to match up right there. Okay, so that's 1 pi bond for later. Then I've got the same thing over here, but I'm going to use a different p orbital. I'm going to use this guy right here. And I'm going to have these overlapping. That's going to be my second pi orbital. There we go. So pi bond here, pi bond there. Okay. My sigma bonds are right here. So let me mark those. 1, 2, sigma. 1, 2, sigma. I've got my lone pairs here and here. So those are actually in sp2 orbitals. So I might ask you that, in what orbitals are these lone pairs? These are in sp2 orbitals. All right, and there you have it. So now let's try CH2O. So first, CH2O has this Lewis structure, H, H, O. Now this gets a little tricky maybe with Lewis structures. Remember, oxygen likes to make 2 bonds, carbon likes to make 4 bonds, so this is going to solve that problem. And we've got our lone pairs there. Okay, so what is the hybridization? This is sp2, and this is sp2 as well. I can tell because there's 1 pi bond. Okay, so now orbital diagram time. I've got my carbon with its 1, 2, 3 sp2 orbitals, and then I've got the unhybridized p orbital right here. Now I'm going to draw this with my oxygen. I did this sideways because I want the oxygens to also be sideways. So here's my oxygen. It's got 1, 2, 3 sp2 orbitals, and I've got my unhybridized P, which I'm going to align with carbons. See, and now you can see why I did it that way. These are going to align and make a pi bonding interaction there. And then I've got my sigma interactions right here, and here, and here. So these are my hydrogens. I'm going to fill those in. I'm going to label those sigma right there. This is my sigma sp2, sp2 between the CO. That's one of these bonds here. And then this pi interaction is the other bond here. So I'm going to write sigma and pi. And then make sure everything's accounted for. Okay, all 3 sigmas and a pi. And then I've got lone pairs, so I want to make sure I show the lone pairs. And what kind of orbitals are those lone pairs in? sp2, okay, sp2, sp2, sp2. See, so make sure you know what are you drawing exactly. All right, and then the last one is HCN. So let's draw that over here, HCN. So this one is a H with a C triple bond to N and a lone pair. First, identify the hybridization. So this is a central atom. This is sp. And this guy is also sp. I could tell because they each have 2 pi bonds. Sigma, pi, pi. And then here's a sigma. Okay, so 2 sigma and 2 pi overall. Let's use our template for sp. If you look back at your sp template, it's sp and an sp. That's my carbon in the center. Now I got my nitrogen also using the sp template. 1, 2, and remember I'm making sure they overlap. That's my sigma bond right here. Okay, in addition to the sp hybrid orbitals, remember we have some unhybridized orbitals along with those. So I'm going to draw 1 pair together like that, and they're going to overlap with each other eventually to make a pi bond there. And then I have another pi bond between the 2 of them. So that's another pair of perpendicular p orbitals that way. So there you go. Now going back, I'm going to make sure, okay, sigma, pi, pi, there, that's taken care of. Now I have a lone pair here. So that's this guy right here. That's in an sp orbital, okay? And then I have, oh, thanks for Facebook. All right, and then I have a hydrogen over here. So I'm going to do that. I'm going to say hydrogen, there's a sigma bond to that with a pair of electrons. All right, there we go. So I know it's a lot, but when you practice it, you'll find that it's actually much simpler than it looks. And if you have any questions, feel free to ask. All right, good luck, you guys.